All right, yesterday we talked about circles, first part of conic sections. Today we're talking about parabolas, and we'll spend another day on it on Monday. But when we're walking our way through a parabola or a conic section, what we're talking about is taking two cones. You all have probably been to a water fountain where they have those little cone cups that are completely, take a drink and then they're worthless because you can't set them down, so you have to throw them away type of thing. So if you take two of those cones and put them point to point, okay, we cut through one of the cones perpendicular to the axis that would go through it, we would get a circle. But if we cut through one of the cones at a diagonal instead of perpendicular to the base, we would end up with an ellipse, which is an oval shape. If we cut through it at an angle, we get a parabola. And if we cut through both cones, we end up with something called a hyperbola. So our focus for today is going to be the parabola. Now, I have a video, but I think I'm going to pass on showing that. And I want to talk about what a parabola is actually defined as. So when we define a parabola, we say that it is the set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus, which is not on that line. So from the focus to the parabola is the same distance as from that same point on that parabola to the directrix, no matter where you are on that parabola. So I've got a little animation that shows you how to create a parabola. So there's our focus and our directrix, and the midpoint is the vertex, the midpoint of the focus and the directrix. And so we just kind of swing an arc, making sure that those two sides are equal. So unfortunately, there's no good way to do it with string or anything like that, rubber band or anything like that. But you want to have equal tension on both portions of that. Okay? So, observations. The focus is always where with regard to the parabola? I like both words, but inside I like better. Okay? So the focus is always inside of the parabola. And the directrix is always outside the parabola. So if you can keep that in mind, then you don't have to worry about figuring out when to add and subtract p. Okay? And when we first talked about parabolas last semester, first quarter, we talked about it having a vertex, and we talked about it having an axis of symmetry. And then when we graphed things, we made sure that it opened the same on both sides of that axis of symmetry, right? So how is that axis of symmetry related to the directrix? It's going to be perpendicular to it, isn't it? Okay. So far, so good? All right. Okay, so next we want to talk about the standard form of a parabola. So in the past we talked about the vertex form of a parabola, and it was good old y equals a times x minus h squared plus k. And we worked with that a lot. But the standard form of a parabola now that we're going to be talking about depends on whether it's in a vertical orientation or a horizontal orientation. Most of what we worked with back in chapter 2 was the vertical orientation. Remember, when A was positive, it opened up. When A was negative, it opened down. And A stretched it or shrunk it, right? And H and K were our vertex. Very similar to this, only now it's going to say x minus h squared equals 4p times y minus k. So if you can remember that the focus is always inside, the directrix is always outside, and when x is squared, we get a vertical parabola. And when y is squared, we get a horizontal parabola, one that opens left or right. Then you're going to have a good foundation for where we're going with this. Okay, so now the thing to remember about when it opens up is that P is positive. And when it opens down, P is negative. When it opens to the right, the y is the part that's being squared, and P is positive. And when it opens to the left, the y is still being squared, but P is negative. So when you're looking at these two equations, notice that the 4P is always being multiplied by the non-squared term. Okay, same thing over here. This 4P is taken times the non-squared term. Questions so far? Okay, so let's see this in action. So we are asked to sketch the graph of y squared equals 3x, and then find the vertex, the focus, and the directrix. So first of all, which term is squared? The y. So we know it's opening horizontally. Okay, so let's think about what this would look like in the y minus k squared equals 4p times x minus h format. This is y minus what? 0. Okay, and I have a 4p times n x minus what? 0. So what's our vertex? 0, 0. Good question. So the 4p is the number that's in front of the non-squared term. Okay. Happens to be 3. This is kind of a messy problem. It's not going to be even or not going to be perfect. So we know that 4p, first of all, is positive or negative? Positive. So we know that it was going to open because the y is squared, you said, horizontally, right? So we know it's opening to the right. Okay. Opening right or left because the y is squared, opening to the right because the 4p is positive. Okay? So now let's figure out what p is. If we divide both sides by 4, p becomes 3/4, 0.75. Okay, so it's not a very nice number, but it tells us how far to go away from our vertex. Okay, so we said that we're opening to the right, so the focus has to be to the right of our vertex, right? And it's going to be p units away from that vertex. So we need to move 3/4 of the way away, and that's our focus. So far, so good. And where's our directrix going to be? Three-fourths of the way the other way, right? Because this is the midpoint of it, right? So we're going 3/4 of the way the other way. And so we'll be at a line that looks like this. So that's a vertical line. Is that x equals or y equals? X equals. So x equals negative 3/4 is our directrix. And then the next question is, well, how wide should this parabola be? Okay. And for this moment, because this is a messy example, we're just going to go ahead and sketch it. And I'll show you in the next slide how we figure out how wide to open it. So far, so good? Should have actually gone this high up and this far down. I'll show you why in just a moment. Okay, so how do we know how wide to make things? Let's look at 3 examples. This first example says 4 times the y minus 2 equals x minus 1 quantity squared. So the x is the squared part, which means that it is opening up or down, right? It's vertical. But because the 4p is positive, it's opening upward. Okay? So my vertex is at 1, 2, right? The part by the x is the 1 and the part by the y is 2. So we have a vertex at 1, 2. And 4p is 4, so what's p? 1. So we went up 1 to get to the focus. Make sure we stay inside of it. Okay? Now, what do you notice about these points B and C? How far are they away from the focus? 2. Okay, so we went up 1 to this way from the focus. Okay, let's look at the blue one. Actually, let's look at the red one next. Okay, the red one has an equation negative 8y equals the quantity x minus 2 squared. So again, the x is squared, so we know it's a vertical parabola. But the p is negative, right? So if 4p is negative 8, what's p? 2. So we went from the vertex was 2, 0. From this vertex, we went 2 down to get to the focus. Okay? But how far over did we go? 4. So we're starting to see a pattern here, right? Okay, let's look at the blue one. This one was y squared, so it's opening horizontally. The 4p is positive, right? So it opened to the right. And since we have a 12 is 4p, what's p? 3. What was our vertex here? 7, 0. And so from here, we went 3 away, right? Because p was 3. And so from that focus, how many did we go up? And how many did we go down? So that helps you figure out how wide to go when you're sketching these graphs. Does that make sense? Okay. All right, so let's look at the next one. So now we want the standard equation of a parabola with a vertex of 2, 3 and a focus of 2, 1. So plot your vertex. Then plot your focus. And then ask yourself, which way is it opening? So which way is it opening? Down. Okay. So when we know it's opening down, we know it's a vertical parabola, right? So which part is squared? The x. So we know we need an x squared. And remember that the 4p always goes with the non-squared term, right? So 4p times y with something. What goes in these parentheses? Yep, the vertex. So x minus 2 and y minus 3. Okay? So far, so good? All right. So how many steps did we move from the vertex to the focus? So what's 4p? P is 2. So 4p is 8. So that's the number that's going here. But is it positive or negative? Why is it negative? Because it's opening down. Okay. So far, so good? All right. So we have our equation, right? So to make sure that we are, yep, so now let's figure out how wide to go. Since we went down 2 from that focus, we're going out 4 in both directions. And that helps us sketch it. And we're sketching, not graphing. Getting a good look at what it's going to look like. And then what would our directrix be? We need to go up 2, right? And it will be a horizontal line because it's got to be perpendicular to the axis of symmetry. So is x always the same or y always the same on a horizontal line? What's the equation of this line? Y is always 5. So y equals 5 is your axis of symmetry. Or not, sorry, is your directrix. Questions on this one? I don't know of one. If you just want to call it DIR, I guess it would be okay. Okay? No specific way that I know of abbreviating directrix. All right, any other questions? So do you see that you don't need all the formulas and so forth? If you can remind yourself, okay, focus is always inside, directrix is always outside. 4p gets me the number of steps to go up or down or left or right, and away we go. So, I like to give you the formulas, but I don't think that they're necessary to memorize all of them. Does that make sense? All right, so here's the last one for today. So now we want to sketch the graph of 0 equals y squared minus 4y plus 4x, and then find the vertex, focus, and directrix. So every time I give you a problem like this, I'll give you graph paper or ask you to grab graph paper and so forth, because I think the graphs are so important to understanding this. So what are we going to do? Complete the square, okay? Which is our squared term? So is it opening vertically or horizontally? We know it's going to be horizontal. So let's get that 4x to the other side, and we'll have a negative 4x is equal to y squared minus 4y. And since we just spent time completing the square with circles yesterday, we should be experts at this, right? What are we adding to both sides? Half of 4 is 2. 2 squared is 4. So if we add 4 to both sides, we satisfy the equation. And the right side is now a perfect square trinomial, which can be written as what squared? So we have a y minus 2 squared. What do we need to do to the left side to make it look like the standard form that we're used to? Take out a negative 4. Factor your negative 4 out. What's left? X minus 1. Yep. So divide both sides by that negative 4. Now, if it makes you feel better to put the y squared term on the left side, that's okay. But remember that your 4p is always multiplied by the non-squared term. So our vertex is 1, 2. And 4p is -4, so p has to be -1. So the focus will be 1 to the left, because you told me before it was opening vertically, right? Or horizontally. Okay. And then p was -1, so my directrix is going to be 1 to the right. The one to the left is the focus. You want to call it F, and V for vertex. Probably should use capital F and capital V. It's typically how we do it. And then we moved one step in, right? So from the focus, how wide do we make it? 2 up and 2 down, right? So we have the vertex, we have the focus, 0, 2, and we have the directrix is what? X equals 2. What questions do you have on this one? All right, so the back side of this sheet is notes for tomorrow. Okay, we'll be working on that tomorrow because we go into a little bit more depth, or Monday, not tomorrow, but Monday. Your book assignment is this.